Let's move on to commute distance. Let's make a number line for commute distance. Now, what if a person asked us to mark off the possible values of commute distance in green and then mark off the gap areas in red? Well, it's not really clear where the gap areas would be, because if we made the number line like this, like we did for number of siblings or number of TVs, this wouldn't be correct because a person's commute distance doesn't have to be a whole number. For example, a person's commute distance could be somewhere in here. It could be 0.5 or 0.6, and it could be in here somewhere between 1 and 2. For example, it could be 1.2 or 1.3 miles, and a person's commute distance could be in here between 2 and 3. So this isn't correct. If we made a number line like we did for shoe size, that also wouldn't be correct, because a person's commute distance doesn't have to be either a whole number or a number with a 0.5. It could be another type of number. For example, it could be somewhere in here. It could be 10.2 or 10.3 miles. It could be somewhere in here. It could be 10.7 or 10.8 miles. So this type of number line also isn't correct. If we move the decimal point out to the hundredths place like we did here, this still wouldn't be correct, because a person's commute distance could fall into one of these red areas. For example, a person's commute distance could be between 0.02 and 0.03 miles. It's technically possible for a person to have a commute distance of 0.023 miles, which would be in here, or 0.035 miles, which would be out here. Or a person's commute distance could be out here somewhere, and it could be 3.157 miles or 3.152 miles. So there doesn't have to be only 2 digits after the decimal point. There could be 3 digits after the decimal point. For example, out here, if we extended the number line, we would have 3.01 and 3.02 miles. The area in between here wouldn't just be a gap area, because a person could have a commute distance between 3.01 and 3.02 miles. For example, it could be 3.015 miles, which would be halfway in between. So this number line is not correct. Even if we made a number line with showing the thousandths place, that still wouldn't be correct, because let's take a look at it. Let's start at 3, and then let's go up to 3.001, and 3.002. Now, if we think about a person's exact commute distance, well, if we record a person's commute distance, the number that we record is obviously going to only have so many decimal places, because we're only going to end up recording it to a certain decimal point. For example, we're probably not going to record a person's commute distance as 3.00001, because we probably wouldn't be interested in recording it to that exact of a number. But what I'm talking about here is not a number that we're recording for a person's commute distance. I'm talking about a person's exact commute distance, not the number that we would record on a piece of paper, but a person's exact commute distance in miles. That number could fall somewhere in between here, and it could fall in here. For example, a number in here would be 3.0002 or 0015. So a person's exact commute distance could be this number, which would fall in between these two numbers here. And it could be 3.0078, which would fall in here. I think that would fall in there. Maybe 0.0005. That would fall in there. So this isn't a gap area, and this isn't a gap area. And if we kept on doing this over and over again, and we kept on moving the decimal point out further, we still wouldn't find any gap areas. It would still be possible to have a person's exact commute distance between the two tick marks. So what this number line really looks like is a solid green number line, meaning we don't have these possible values that are separated from each other like this. We don't have these marked off possible values. What we really have is a solid continuous stream of possible values, meaning pretty much anywhere on this number line is a possible value, which is why the entire number line is green. It's all possible. So the word discrete means broken up into pieces or separated. So here, the possible values are separated from each other, which is why we say that it's a discrete variable. Since the possible account balances are separated, account balance is a discrete variable. Since the possible shoe sizes are separated, shoe size is a discrete variable, and the number of TVs and the number of siblings also have these possible values that are separated from each other, because only whole numbers are possible. But down here, the possible values are not separated from each other. You could think about it as we have two possible values here, and they're touching each other. They're not separated from each other. So whenever you have two possible values that are next to each other, like this, on the number line, there's no gap between them. So the two possible values that are next to each other on the number line are really just touching each other. There's no space in between the possible values. So it's a continuous variable. Temperature, height, and amount of time spent on homework would also be continuous. They would also have this type of number line with no gaps between the possible values. Now, when I talk about commute distance, temperature, height, and amount of time spent on homework being continuous, remember, I'm not talking about the number that we would be writing down or recording. I'm talking about a person's exact commute distance, or exact temperature, or exact height, or the exact amount of time a person spends on homework per week. Those would be considered continuous. You could think of a discrete variable as having possible values that are like stepping stones. For example, when a person starts buying more TVs, the person's number of TVs goes up one at a time. This is what I mean. If a person hasn't bought any TVs, the person is right here. The person has 0 TVs. Once the person buys his or her first TV, the person's value goes from 0 right up to 1 without going through any of these values in here. When a person buys a second TV, his or her number of TVs immediately goes up to 2. And when a person buys his or her third TV, the number immediately goes up to 3. So when a person's value increases, it increases in steps, one step at a time. The same thing for shoe sizes. A person's shoe size will go up from 10 to 10.5 without going through any of the values in between. A person will wear a shoe size of 10 until it gets to be too small, and then when a person buys his or her new pair of shoes, the new size goes right up to 10.5. So when the person throws away his or her old pair of shoes, which was a 10, and buys his or her new pair of shoes, which is 10.5, the value goes from 10 right up to 10.5. And when these shoes get too small, and a person buys shoes that are 11s, that person's shoe size goes right up to 11 when he or she buys that new pair of shoes. So the value goes up in steps. The same thing happens with account balance. When a person's account balance increases, well, a person's account balance can only increase 1 cent at a time. I mean, that's not correct. What I mean is, a person's account balance can't go up any more slowly than 1 cent at a time. So if I wanted my account balance to increase very slowly, what I could do is I could deposit 1 cent at a time. So I start off with an account balance of 0. If I have no money in the bank, and then when I deposit 1 cent, my account balance goes up by 1 cent. If I deposit another penny, it'll go up to 0.02. If I deposit another penny, it'll go up to 0.03. But I can't deposit money in smaller amounts than this. For example, I can't deposit half a cent and go up to here, and then deposit another half a cent and go up to here. So my account balance is also increasing in steps. So all of these are discrete because the value increases in steps. But what about something like commute distance? Think about this. If I want to increase my commute distance, let's say that this is my house and this is my workplace. Right here. And let's imagine that I can actually push my house and my school further apart. So I push my house out this way and I push my school out this way so that they get further and further apart from each other. If I was able to do that, the distance, the commute distance between my house and my school wouldn't increase in steps. For example, it wouldn't be like the distance jumps by a certain amount and then jumps by another amount. It would just continuously get larger and larger. For example, it wouldn't be like the distance jumps like this and then jumps again like this. It would just smoothly get or continuously get to be a larger and larger distance if I pushed my house out this way or if I pushed my school out this way. What about temperature? When it gets hotter, or I mean when the temperature increases, the temperature doesn't increase in steps like it does here or here. The temperature just sort of continuously gets to be hotter and hotter as the temperature increases, and it gets to be colder and colder as the temperature falls. But the temperature doesn't, when it gets hotter, the temperature doesn't jump from 60 degrees right up to 61, or it doesn't jump from 61 right up to 62. It just continuously gets higher and higher, or continuously lower and lower. And I think that makes the point. So this covers the difference between two types of quantitative variables, which are discrete and continuous.